Hi guys, it's Dr. Mohammed Usman and I am back with another video on the session of data diagnostic, and we are moving toward our further graphical excellence series. So this video will be telling about unintentional fibbing with the visualization, and this will be the very first example about the Warmest years. Basically, when you are making up the visualizations, you can intentionally change the data or unintentionally change the data. So when you will do intentionally or unintentionally changing the data, then it will create problem in your visualization. Basically it might not be your motive to change the visualizations, but you can make up a bad visualization. But making a bad visualization is not bad as we think. We should make bad visualization at some point to learn and discover new things. Sometime when you make a bad visualization, you are going to discover a very new kind of visualization. So over here we will discuss with the Warmest year example, and this from Climate Central 2013, and we will be talking about what is bad in this visualization and how can we find the solution of this bad thing, and we can move toward the graphical excellence and we can work on it to make it understandable to the user. So first of all, as we have talked before many times, what kind of graph it is. If I talk about it, then it is a 3D kind of graph, and if you read about it, what kind of errors you can find out it. So I can just give you a time and you can discuss those errors and find out those errors, and just write down on the paper, and you will find out there are many more errors in it. So I will just give you the what kind of potential issues are in this visualizations in the next more slides, and you can just review back it what kind of errors you have found during your analysis of this visualization. So first of all, the first error is that range on the y-axis is from 53 to 55 degrees, and the bar chart should start from the 0 on the y-axis. But if we go on this one, the bar chart is not starting from 0 on the y-axis, it is starting from 53 to 55 degree. What about before the points before on the that axis? Also small ranges, and there are small changes in the visualization. When we are talking about the Warmest here, we can talk about the time from 0 to 53 degree or 48 degree, or we can move from highest to lowest value. Then there is also a problem of sorting the values on the x-axis by the y value. We should not sort the values on the x-axis by the y values. We are having at this moment now unordered data that can be sorted by the y value, and we are also we should also work on ordering the data on the x-axis. Like if you can see, from 1921 to 2012 the data is not sorted, and similarly like on above the data is not sorted, something is greater and something is smaller. So basically we are talking about the years these should be sorted out. And some more potential reason in this one is that we have the suggested use of colors. As we have studied before, we use the colors with greater care. Colors provide us the important knowledge. Why only one graph or one bar is in red color? Why all the bars are not in the red color, whereas the temperature is also high according to the visualization? It is showing that there is just a slight difference between the highest temperature and the lowest temperature. Also there are use of orange and red color are the warming colors, and there are the alerting colors. So we should avoid using the red or the orange colors or the yellow colors, because they give us an alarming session. Also there is intensity of the background, like it is very dull, it is like black and purple, and it is not just matching up with the front end. So basically when the user will try to read up the visualization, it will just mix up with the background, and the background will not be clear. So the density of every visualization is important, the coloring of every visualization is important. We don't need to label the data on the x-axis or y-axis. Similarly, like when you are labeling data above the bar graph, it also gives a very bad impression, because when you have to write the values on the top of the bar graph, then why you are making the bar graph, the user can read from the x or y axis. Also the accuracy on is 2 decimal points on the labels, whereas when we talk about on the x-axis or y-axis, the accuracy is less. We are going to talk about that it is 54.32, but when you see on the y-axis it is 55.0. So what kind of accuracy we are trying to provide to our visualization? So these are the some problems in our visualization. Then the bigger another problem is the 3D issue. 2.5 or 3D issue we have talked in the very start. We will not go for the 2.5 or 3D issue, because these visualization take a lot amount of ink, they take a lot amount of space. So we want to utilize this space, like you have studied previously. You want to utilize the space for making up the greater data in a very small space. So basically we have to work on it. Also the axes are skewed, because when we are talking about x-axis or y-axis and in 3D visualization, then we are going into the 3D, then we are not able to analyze that which point is able to compare to the y-axis. The shadows, the gradients, the 3D bar chart, which are encouraging the comparison, but they are not actually giving you the comparison. Also, the axis line sit behind the bars. When we are talking about the visualization, we have seen that the bars should be on the balance out on the same line, or when we are making up the line chart on that one, the bar should be with those bar graphs or according to the background of the visualization. But these are not matching with the height of the visualization. Like if you can see over here, the lines are just according to that the 53.81 is not even matching with the very first one. Similarly, like 54.14 is also not matching. So basically we are making up the visualizations and we are just putting the bar according to just our own knowledge. So this kind of visualization lead to misconception and misalignment of the data, and it is not readable or clear to the users. So how did this happen? Basically, how we can solve this issue, if I can talk directly, we have to sort out that we have to compare the 2012 with the previous hot year, so they should be aligned. We have to remove the context provided by the other year. We have to reorder the x-axis to make the comparison easier, because when we have an order data, the x-axis will be providing from 1992 to 2012. If they will be ordered, then we are easy to find what kind of year was the warmest. So similarly, like we have to change on different average temperatures. We have to make on different background changes and the foreground changes. So in next slide you will be see that how we can convert into an actual good kind of readable visualizations from a normal user to an advanced user. So let's think about this was our number one visualizations, and we converted into first of all 2D visualization. At this moment you can see that we just converted into a 2D visualization. We have put the 2 decimal points on the y-axis, and we have sorted we haven't sorted out yet the axis, but in the next one we will sort out the axis. So you see over here that we have worked on the sorting out the axis, and we have just removed the labels on above of the all the charts, and we have gone from 3D to 2D, and we have just put a normal ink. So it is also providing you the same concept, same visualization, but in easier concept. If I talk about 1921, I can just see that. If I talk about 1999, I can see just in order. So we have worked on the ordered data in this one, and we have changed the x-axis from 2 decimal point to 1 decimal points according to the data available. Similarly, like we have to now further work on the warmest year, and we have to work on all the records and all the data that is available to us. So basically we have to conclude and include all the other years. So we have included all the other years from 1900 to 1910 to 2010, because we are warmest year on the record for all the US data. So because we have made up that, so we previously we have just bar charts over here, and we have a greater amount of space that is not utilized, and when we have utilized that space, we can include data from 1900 to even 2010, and it is clear in that visualization. We can easily include, and furthermore we can further include to the 2012 data and just highlight the warmest year over here. So it is just a way to use the visualization, but at this moment it is not that much clear. There are also some errors in this one, like we have a very light color on the white background, so we have to improve it further. And what we have done, we have removed the bar from this one. You can see that we have removed the backgrounds, and we have just gone on the line chart. So when we talk about the line chart, and we have built up to average line, so it is easily giving you a larger context of data from 1890 to 2012, and it's just telling you the what is the warmest year by giving you some point. So basically when you are making up the visualization, you have to consider all the different points of that visualization, and it is not necessary that what you are trying to show like 3D and it looks good for you, it looks very attractive, but it is not good for the user or the understanding. So basically we have to utilize model space, we have to utilize the color, we have to make sure that we are making up a good visualization. So this example was up to here of this topic. If you like my video, do subscribe to my channel, and you can earn the training certificate. The process is as follows. So what you are waiting for, do visit my YouTube channel and like and subscribe to my videos.